During one of the moon landings, the astronauts did several physics experiments and demonstrations, one of which was to compare the falling speeds of a feather and a hammer. There's actually a video on the internet you can find that shows this demonstration. Let's say that the feather is dropped on the moon, so there's no air resistance, by the astronaut doing the physics demonstration. The feather drops a distance of 1.9 meters to the ground, taking 1.54 seconds to fall. We want to know what is the speed of the feather as it hits the ground and what is its acceleration, or in other words, what is the moon's value of gravity. Drawing a velocity time graph, the feather would start at 0 velocity and get faster. The distance it covers to the ground is 1.9 meters, and the time it takes to get there is 1.54 seconds. We want to know the final velocity of the feather, and we want to know the acceleration of the feather. So, V initial equals 0 meters per second. V final is what we want to know for part A. Acceleration is what we want to know for part B. Time is 1.54 seconds, and the distance is 1.9 meters. For part A, I'm solving for velocity. I don't know A. I don't need to know A. I think I'll pick the third equation, which does not involve acceleration, which I don't know yet and haven't found. So for part A, delta x equals 1/2 v plus v initial times time. I'm solving in this case for v. I'm going to go ahead and do the algebra first, just to demonstrate that. So I would start by multiplying by 2 to get rid of my fraction. I am going to recognize that since v initial is equal to 0, it doesn't contribute to my equation in the least, and I'm going to divide by t on both sides. The final result of all of that is that 2 times delta x over t will equal, I counted out the half, I counted out the t, the v initial wasn't adding anything anyway, and so I'm left with just the final velocity that I'm trying to solve for. So v equals 2 times 1.9 meters over 1.54 seconds, and on my calculator, 2 times 1.9 divided by 1.54 is 2.47 meters per second. For part B, I would like to know the acceleration of the feather on the moon with no air resistance. I'm looking for acceleration, so really any of the other three equations that I haven't already chosen would be fine. Let's use the second one. Delta x equals v naught t plus 1/2 at squared. Really kind of an arbitrary choice. Not too arbitrary. I don't know the right, if the final velocity, if I did something wrong, then I wouldn't be depending on that as my second calculation. Again, noticing that v initial is equal to 0. 0 times time is still going to be 0. Add that to anything, it's still going to be 0. And so the v naught times time doesn't contribute anything useful to my equation. I'm solving for acceleration. I'm going to do the algebra again, so I'm going to multiply by 2 on both sides. That will get rid of my fraction. I'm going to divide by t squared on both sides. That will get rid of t squared, leaving me with acceleration all by itself. So A will equal 2 times delta x over t squared. And somebody's looking at this and saying, well, wait, aren't those just the same thing? Notice that in one of them I'm solving for velocity and it's just time, and the other one I'm solving for t squared. I'm solving for acceleration, it's t squared. And also, they came out to be the same because the initial velocity was 0 to begin with. Had the initial velocity not been 0, these two equations would not look nearly as similar as they do. Solving, putting in numbers, 2 times delta x, 1.9 meters is the distance. The time is 1.54 seconds. I'm going to square that. That was my phone giving me a text message. I apologize. And on my calculator, solving 1.9 times 2 divided by 1.54 squared gives me 1.60 meters over seconds squared, because I'm squaring down here, as the value of acceleration on the moon, or the moon's gravity. You can look it up on the internet. That's pretty close.